皆さん、おはようございます。Good morning. I have to switch to English. My Japanese is very rudimentary at the moment, but I'm trying, so maybe next time. First of all, I'm honored to be here to give a keynote at the Kaigi on Rails this year. Thank you, everyone, for coming, and thank you to the organizers for inviting me. Let's start our talk. First, a bit of introduction. My name is Vladimir, or Vova, or Palkan, as many here refer to me. That's actually my GitHub handle, not my name, but that's fine. And GitHub is a place where you probably have seen me before, or one of my open source projects. There are a few I would like to highlight today. First of all, it's Anycable. It's a real-time server for Rails, and not only Rails applications that make real-time features like scalable. It's RubyNext, Ruby transpiler that allows you to use modern syntax everywhere and bring your own syntax to Ruby as well. We also have a TestProf toolbox, is a test optimization and profiling toolbox that helps you to speed up your Rails tests, which are typically slow. But open source is not the only thing I do for a living, unfortunately. I have to work, and I work at a company called Evil Martians. We're a consultancy. We help in startups and larger products to bring their cool ideas into life or solve their growth issues. There are a few other marchers here at the conference. They're based in Osaka, so come say hi to them, grab some stickers, invite them to your local meetups, Kaigis. Unlike me, they speak Japanese, so please talk to them. Okay, that's all about business. Let's go back to open source. So recently I discovered that it's going to be 10 years since my first Rails commit, and that made me think about the years that passed. And it's not only about the contributions to Rails, actually. It's 10 years of my commitment to Rails. Rails kind of changed my life and still plays an important role in it. Rails brought me here today, right? Which I'm grateful for. And in my keynote, I'd like to reflect a bit on my Rails way, the years of Rails and me. Yeah, that's how we're going to go back after the conference to the city. And yeah, that was quite a journey full of twists and turns. And I invite you to take a look back and forward with me. And the plan for today is as follows. So I want to talk about the Rails way. What does it even mean? What challenges does it hide? And how not to lose its signs when you move fast, because it's really easy. So, the Rails way. For many developers, for Ruby developers at least, I think the first thing that comes to mind when you hear the Rails way is the book. It's just a book. It's a really good book. That's actually my copy of this book. It's already 10 years old, and I still have the bookmarks. I still kind of keep them just as a memory. So 10 years ago, I also thought of the Rails way as like, oh, that's a book. That's some technical details of how Rails works or how you should use it. But today, I can say that I perceive Rails way a bit differently, because it goes far beyond the code. It's not just how you craft, how you engineer your application. It's more about the methodology of building web applications. Not only Rails, actually, but it originally comes from Rails, but could be applicable to anywhere. And it's not just a methodology. I would say it's even a philosophy, because it changed the way you think about building software. We can say that, well, I can say, that's my view of the Rails way, that it's based on three main ideas. First, it's optimization for productivity and happiness. Then it gives you freedom from decision making, or amakase. And it's also one of the important parts of the Rails way is design. It's design for scalability. Where scalability is not about performance or RPS and all that numbers, but it's about an ability to execute as fast as needed by dropping as many resources as needed. So that's what scalability means. Technically, Rails way is based upon 4 things: software, tools, and ideas. First of all, it's Ruby. Ruby brings productivity and happiness to the Rails way. Without Ruby, there is no Rails way. And there is no Rails, of course. An MVC, a model view compiler paradigm, and conventional configuration principle spare us from writing boring code and focus on writing the code that brings real product value. And complexity compression is the principle that helps us to get started and quickly. And all of that you got simply after running Rails new. Every new Rails application comes with all of this predefined for you. And Rails claims that you can scale from Rails new to IPO. And we know that's true. There are many great companies built with Rails. Rails 8, in particular, focus on scaling from 0 to 1, from nothing to something, as quickly as possible, eliminating all the barriers on your way. Let's take a quick remark of what has changed in the very recent version. It actually hasn't been released yet. It's just a release candidate, but it's going to be soon. So finally, we got some missing pieces in the framework. We got authentication is a way, like it's just a generator, but still, it's more than nothing. We got active deployment, also known as CAML. And we got what I call solid infrastructure, a set of tools that allows you to run a fully working production application without relying on additional infrastructure or vendors. So we can say that the Rails 8 way shifted a bit in its philosophy to the goal of optimizing for getting from 0 to 1. It's a one-person framework now. But the question is, what's going to happen after 1? There are infinitely many steps towards infinity from 1. Will the Rails way work after we reach the 1 and start to grow further? And that's my experience here tells me that, well, scaling beyond 1 is tricky. So it's not always a way full of productivity and happiness. Let's explore the challenges that comes when we reach a certain point in our Rails application development. First, let's talk about the nature of Rails as a web application framework. Web applications form a specific class of software with its own distinguished features. The primary purpose of a web application is to serve web requests, is to implement a request-response pipeline. We can see it as an assembly line. When you have a request, entering a third workstation, passing through others, and returning the final product, the response. In Rails, we have just 3 processing units by default. We have a controller that receives the task. It uses models and finally views to wrap the final result into the response and present it to the user. So model view controller paradigm dictates how we organize our code, our business logic in the app. It works well in the beginning, but it's getting harder to fit all the business logic when you have just 3 buckets to fill as your application grows. Applications tend to diverge from the Rails way in an attempt to adjust to the changing requirements and the growing complexity of the product they want to build. Why does this happen? Well, my understanding is as follows. Rails gives you a solid frame, a foundation to build your product on top, to get quickly on tracks and deliver the value. But Rails is not one-size-fits-all solution. It's hard to put every possible feature, every possible functionality into the framework. It only covers the most common ones. Rails leaves you some gaps to fill in this frame. And filling these gaps must be done wisely. You shouldn't just try to use whatever you have at hand or found on Twitter or on Reddit or wherever and put it into your application, because it could corrupt the frame, could make framework less efficient, could hurt your productivity, well, and happiness, of course. It could turn your application into a monster. And dealing with such monster code bases is one of the main challenges that Rails application developers see. Yeah, that's a funny thread on Reddit with this interesting comment. That made me smile not just because I'm Eastern European, but because I was that kind of guy, bringing all the fancy gems and patterns into the Rails applications just because I thought that were cool. And I had no idea what's going to be after me. I didn't care about what's going to happen next. Well, luckily that changed. Why do monsters born? I think monsters appeared because developers either don't understand or misinterpret the Rails way. That's one of the examples of misinterpretation, that Rails just gives you structure and you're on your own. That's not true. Rails framework gives you structure, yes. Well, you run Rails new and you have a structure and you fill it. But Rails way gives you guidance. It teaches you how to stay productive and happy with your application as you grow. But it's easy to miss the science of the Rails way if you move fast. It's easy to get lost. So let's talk about now how not to get lost. The full version of my How Not to Get Lost guide is available as a book, so it surely will take more than 20 minutes to talk about it. The book is available, unfortunately, only in English right now, but I'm working hard to make it be translated into Japanese. So if you'd like to have it in Japanese, please raise your hand. I just want to see if there is a demand for the book. Not really. Or if you know a Japanese publisher who would like to work with my publisher, please come and tell me, because all this publishing thing is difficult. It's much more difficult than writing code. Okay. What I want to say here about the book is there is a raffle lottery. I'm giving away a few copies of the book. Scan the code or follow the link. There are some instructions in both English and Japanese. And doesn't work? Oh. Not, okay. Oh my God. Okay. We'll figure out later, probably post it on our conference app or whatever. We'll need to figure out what went wrong. Sorry. I still need to give away these books. But let's talk about, not what this book about, but how to embrace the Rails way for growing applications, or how to find the extended Rails way. That's how I call it. And the extended Rails way could be expressed as a combination of two actions. You must master Rails and extend Rails. That's how you can stay productive and continue to deliver features at a reasonably fast pace. Mastering Rails includes learning how the framework itself works, how it's designed, which ideas and patterns are used throughout the framework. Find out how Rails scalability is reflected in the framework architecture, how it's possible to scale from 1 to n without even changing the way you write code, by just changing the infrastructure components. Learning how Rails make it possible would not make you a more experienced software engineer, but would help you to understand how to grow with Rails. Of course, you need to embrace the principle of conventions, understand why they are like this and how to use them in your own code. And you need to learn how to use Rails minor components like sub-frameworks or building blocks like active model, active support, site work, and so on. As you learned everything, you're ready to extend Rails. And extend is not a kind of accidental verb here, because it's easy to mix Rails with something else, to bring some foreign ideas and think that it will help to build your application. But from my experience, the only way to grow is to extend Rails in a way that a framework offer would do. Let's take a look at our assembly line example again. What should you do in real life to make your assembly line more efficient? Well, we can introduce a new workstation. We do that by separating concerns or responsibilities of previous, like larger stations into smaller pieces that focus on particular part of the process and make it more efficiently than focusing on everything else. And that's the same idea could be applied to a Rails architecture. Separating concerns requires introducing a new abstraction or an abstraction layer. Because, well, in the case of a software framework, abstraction layer is your assembly line workstation. But introducing abstraction is a difficult task, because if the abstraction is chosen or crafted poorly, it would bring more harm than value to your application development. We need to learn how to develop abstractions that would fit the framework, would fit the Rails way. And that's what I'm going to share next, my 4 principles of crafting Rails abstractions. First, you need to provide a Rails-like interface, Rails-like developer experience, and compatibility with the existing framework components. Your abstraction must look like a Rails abstraction. And the best way to do that is just to think as a Rails framework offer, not a custom application developer. Just try to think, oh, I'm not writing this custom thing within my app. I'm just writing it within Rails repository on GitHub and trying to make it work fine with everything else they have there. And that shit of thinking about software development would be the first step towards creating a better abstraction. Since we introduced new abstraction layers, and it's going to be maybe many of them, we need to figure out how to draw the boundaries between them. Because if there are no boundaries, there are no layers. It's just chaos. And for that, I found that it's useful to incorporate the layered architecture ideas. They really work well for separating abstractions in web applications. One idea, one particular thing about layer architecture that I like to note here, that when we follow the principles, we ensure that every abstraction, every object in our system belongs to a particular layer. And we ensure that the data flows only in one direction, from top to the bottom. So each layer only knows about abstractions below it, not above it. We also can put additional restrictions on how far below we can reach. Altogether, these basic principles of layered architecture would help us to reach naturally loose coupling of our code base. That's one of the key features of the maintainable code base, because if you have high coupling, it's really hard to grow with this software, how to introduce changes or fix bugs and so on. Rails architecture could be easily associated with a layered architecture. Every Rails built-in component belongs to a particular layer. We have them organized, and this perception of Rails application works really well. And what we need to do, we need to put our components onto this diagram in a way that it fits it. Then the third rule of Rails-ish abstractions is that you must prefer extracting abstractions from your code base, from your business logic maybe, instead of introducing something that just worked in some other application just because it's, someone told you that's a cool idea or it's a great pattern. That's a big difference between using a design pattern and an abstraction, Design pattern is just a tool, and abstraction is more a way of thinking about how you design software. And you need to find this meaning in your code base. Finally, the final fourth rule says that we need to separate both responsibility and complexity levels. So separation of concerns or single responsibility principles are inherent into abstraction by default. But what about complexity? Well, that's another point of view on how to separate code in your code base. Mixing code that requires different level of experience makes it hard to work with the code base, especially for less experienced developers. It's fine to use advanced concepts like functional programming, monads, and so on in your code base. Just try not to mix it with plain Rails functionality. Let's take a look at the example. Here we have a model which has the problem of unseparated complexity. It starts as normal Rails, like validations, associations. Everyone can read it and understand what's going on there. But then we have some not so normal Rails. The code is of a much higher complexity than the code above. But the problem is, it steals the attention of the developer working with this class. It makes everyone on the team not to deal with this model anymore because it's hard to understand what's going on there. That's an example of the indicator that's something that should be extracted somewhere else. And we can do it. We can separate complexity. We can make our model look like a typical Rails model with some scope, but, well, for most cases, you don't care about what's going on in there if you're not using this scope. And we can extract this query building functionality into a query object right here. And yes, it still uses some advanced techniques, but it lives in its own file. No one touches for years, and no one cares. It doesn't affect the overall team's productivity. And that's just a simple example of this kind of refactoring and extracting abstractions, finding them in your code following these principles. Let's take another one, a bit bigger, covering all the principles. So recently I worked on a feature in one of my projects that required me to kind of upgrade the user experience of dealing with this long multi-field form. What I wanted to do is to turn it into a multi-step wizard with useful instructions, tips, and so on. So that's the product feature. We want our product to be more user-friendly. But how to build this with Rails? Using just plain Rails, nothing else. Not bringing gems, front-end frameworks, or whatever. Just good old HTML-first Rails. Well, I tried to make an attempt following the classic Rails approach, and I ended up with this. Let's see how our model changed. So we could imagine that before we only had some validations, and that's it. Now we have tons of methods that deals with stepping backwards and forward logic for our wizard. And we actually have some state in our model that doesn't belong to the model layer, to the domain layer, if we take a look from the layered architecture perspective. That's actually the responsibility from the presentation layer. Those two factors, this crossing the boundaries of architecture layers and introducing a lot of complexity into a model class, are just indicators of a poor design. It introduced coupling, it reduced maintainability, it just pain to work with. Well, it was written by a senior developer, not me. Let's take a look how the same developer approached the controller refactoring. And we can see that we have now some storage mechanism to keep state between steps, because we have multi-step form we submit on every step. And now we have to store the data somewhere. Well, let's use session, why not? We have some back action, which is like not Rails-ish, which just brings confusion. That happened because, well, Rails doesn't provide multi-step form functionality out of the box. It's not explicitly, at least. And we tried to fill the gaps. We tried to fill this particular gap by, well, writing some code. Even in this case, someone told us to write this code. But if we try to embrace the extended Rails way idea, we would know that, oh, there is actually a use case for introducing a new workstation to our assembly pipeline. The workstation that's going to deal with this, was going to model this logic of multi-step form. And for this particular use case, I would go with a form object. Form objects help you to model complex user interface features related to submitting data in any form. There are many things you can implement at the form object level, like custom context-specific validations that are not strict validations that must appear in your model, but only for this particular user interface. You can add additional feedback to user. You can do like form to database data mapping, because it's not necessary to change the database every time you decided to switch from, say, Boolean field in a form to a num or whatever. So form objects are useful, and but we need a way to craft them in a way that would work with Rails nicely. Let's take a look at the final example of the form object. So now we have a new object, a new abstraction, and it's clear from its name what it's responsible for. We can understand that, oh, this piece of code is for this particular form in our interface. We have the form fields defined, and we even have some custom mapping. We decoupled our UI form from the database schema because we don't want to deal with this the way the actual data is implemented. Our front-end team, our designers, don't want to know about how we model our data. They just gave us a mock-up with a new form and said, okay, let's build it. And if our data model doesn't match it, well, we can just map it here. But that's not the only benefit of going with form objects, of course. We can get additional validations that only make sense within this context. Everything else we can get from the model. Again, we don't need to duplicate logic. We can add callbacks to trigger secondary operations or some other events that must happen as the form submits. And here we use, again, the Rails interface. It's just like in the model, after commit, do something. Finally, this is our wizard logic, our multi-step form logic. To implement it, we created a special object, we call it wizard, and it's nothing more than a deterministic finite automaton or state machine. And we use another abstraction here. We do not try to implement all the automaton logic within the same form object or any other class. We extract it into its own abstraction. I call it workflow, based on the gem I use for it. That describes, well, it's some DSL, it's a matter of taste. I am sure everyone's going to like it. But it clearly describes the possible states and transitions. And it's much easier to change our multi-step form logic by changing this single object responsible for the state. One thing I want to point here is that both our form object and workflow object have some base classes. And that's actually a hidden part of the first principle, being providing a Rails-like developer experience. In Rails, we have base classes for everything. We have action controller base, we have active record base, active job base, and so on. They are not there just accidentally. They are there for the reason. And the reason is to share the common functionality, to provide, to eliminate as much boilerplate in your classes as possible. And if you craft an abstraction, you must have a base class, because one of the key reasons to extract an abstraction is to solve common problems for this particular layer, for this particular part of business logic. So you create a base class, and that's a base class that actually makes your abstraction fit the Rails way. Let's take a look at our application form base class. So here, sorry, here we can see how we use the idea of leveraging Rails building blocks. We use active model to provide validations and type conversions and attributes API. We use active support to define callbacks. We have some additional value added to our abstraction. That's actually not a part of Rails. That's an after commit everywhere gem. One of my colleagues who is sitting here, by the way. So, but it makes our abstraction not only providing a good interface, but also providing additional safety. So we make our code more secure by default. We define a clear interface because every abstraction requires a clear interface. So we deal with form objects. Let's call the only method that must be implemented in the children classes submit, because that's what you do with forms. You submit forms. You do not use generic call or save or whatever, because it's not about saving, it's about submitting a form. And finally, that's my favorite part of it. We have some tricky active model name thing with nils and whatever's going on here. But that's an important piece. That's the piece that glues our abstraction with the rest of the framework, in this case, with action view. Let's see how it works. So this is our original template. It's just a form for cable and so on. And cable is a model. So it's very classic Rails. And it results in this HTML. We can see that, I can actually do this. Oh yeah. So that the model name is reflected in the URL, in the namespace for inputs, and so on. Rails does all of this automatically because you use a model as a form for inputs. But now we can use our form object and everything stays the same. We don't need to specify the URL manually or scope for field inputs, nothing. We just tell Rails that we're going to use the model name, that's actually the feature that is used for all the helpers, the same as the model name, so cable in our case, and everything stays the same. So we don't need to change the way we write forms with Rails helpers. And it's not only for helpers, it's for URLs and so on. So that's an important bit of our abstraction. Let's take a look at the controller. Here, the code now looks pretty much the same as the default Rails scaffolded code. We only replaced model with a form object, but the flow looks the same. There's a tiny bit here where we check if it's valid, then we go to the next step. If not, it's a validation error. We should just render this error. So that's the only change we made here to switch from a single page form to a multi-page form. Finally, let's take a look how we implement state persistent between steps. And we don't use any session storage or whatever storage or cache. We just use HTML. We can keep our intermediate state right within the form when we re-render it by just using hidden fields and using our wizard object to decide whether we need to show these inputs or hide them. And that's how our workflow, our state machine pattern, again, turned out to be useful. We don't care about the actual order of steps here or how we got there. We just ask our state if we allow to do that or not. With this implementation, we can easily introduce form steps that actually have no inputs, just some notes to the user. And we also don't need to deal with custom controller actions. We can just use the same new action to go back. We just update the desired state for our state transition. And that makes our refactoring, our switching from models to form object as painless as possible. We added just some ifs into the template, and that's basically it. That's the major change here. So our abstraction is complete. It's now a part of our Rails, our version of Rails, our extended Rails that we use to continue building our application. So it fits our puzzle well. And that's just one new thing we added to our layers. And in the real life, we add more new abstractions, but following the same principles without breaking everything apart. So the key thing is in growing with Rails is to not fight the framework, but embrace it and try to extend it and try to be friends with the framework. For that, you first of all need to learn Rails, become a master of Rails. And then, by following these 4 rules, you can make the pieces of your application puzzle fit together. And my talks puzzle is finished at this point. Thank you. ありがとうございます。